Okay, let's find the local extrema of f of xy equals e to the 4x minus x squared minus y squared. Start by taking the first partials. The derivative of f with respect to x, well, the derivative of the exponential function is the exponential function times the derivative of the exponent, this time with respect to x. So that's going to be 4 minus 2x. And I'm going to put that in front, like so. And the derivative of f with respect to y, again, take the derivative of the exponential function and get the exponential function. And then by chain rule, multiply by the derivative of the exponent with respect to y, which is just negative 2y. Now remember what you do. To find your critical point or points, set these partials equal to 0, and you solve the resulting system of two equations, two unknowns, which I'm encircling here. But remember, the exponential function is always positive. So basically you can ignore it. And what determines when this f sub x equals 0, for instance, is when 4 minus 2x equals 0, since e to this exponent is always positive. So you can get a simpler set of equations, 4 minus 2x equals 0 and negative 2y equals 0, if you realize that the exponential function is always positive. Of course, you solve these two equations, you just get x equals 2, y equals 0. So this guy is your single critical point. Okay, we're going to apply the second derivative test to see whether or not a local max or local min or none of the above happens there. Okay, so what do we need to do? We need to take the second partial derivatives. So moving back up for a second, I'm going to take the derivative of this guy with respect to x, and that'll give me f sub xx. So remember what I have to do here. I've got a product of two functions, 4 minus 2x times the exponential function. So I'm going to take the derivative of the first times the second. The derivative of the first function, 4 minus 2x, is just negative 2, times the second function, the exponential function, e to the 4x minus x squared minus y squared, plus the first times the derivative of the second. Now, okay, the derivative of the second is just going to be the exponential function times the derivative of the exponent, which will just give me another factor of 4 minus 2x. So I'll just square that guy, and there's your derivative. Okay, so now I'm going to do something similar for the derivative of f sub y to give me f sub y, the second derivative, second partial derivative with respect to y. F sub y. Okay. The derivative of the first would just be negative 2. So the first function is negative 2y, second function is the exponential function. The derivative of the first is negative 2 times the exponential function, using the product rule, plus, well, I'm just going to leave the minus there, so minus 2y, the first times the derivative of the second. Well, okay then, but that just squares, well, okay, so you take the derivative of the second and take the derivative of the exponent by the chain rule, and you got to multiply by another negative 2y, which essentially is going to make it plus 2y squared. Okay. So that gives me negative 2e to the 4x minus x squared minus y squared plus 4y squared times that exponential function. Okay. So I need to evaluate the exponential function's that we have. Well, I need to evaluate. Excuse me. I need to evaluate the partial derivatives that we have, the second partials, at 2, 0. Before I do that, let me go ahead and find the mixed partial. Okay, so if I go back, way back up here, and take the partial of f sub x with respect to y, that'll give me the mixed partial I need. So that's just going to give me, if you think about it, since the exponential function is the only one that contains a y, or a y squared in this case, I can consider 4 minus 2x just a constant. So when I take the derivative of this guy with respect to y, I'm just going to end up with another factor of negative 2y in front by the chain rule. And get, I'll just put the negative 2y in front. Negative 2y times the quantity 4 minus 2x times e to the 4x minus x squared minus y squared. Okay, so I've got the second partials, and I need to evaluate them all at the critical point 2, 0. And you really want to do that first, otherwise it's just going to be a mess. Well, okay. If this may be helpful. Let's factor out the common factor here. In f sub xx, let's factor out the exponential function. And if you do that, you'll get, well, inside you'll have negative 2 plus 4 minus 2x quantity squared, and then times the exponential function. And then I can do the same thing with f sub yy, just to get an easier expression to deal with maybe. Factor out the exponential function, and I'll have negative 2 plus 4y squared times the exponential function. And then I'll just focus on these three functions, these three versions of my second partials. And okay, if you evaluate, let's do f sub xx first. At 2, 0, what do you get? Okay, so I'm looking at this guy. Well, this guy right here, the 4 minus 2x quantity squared, zeroes out. So I'm just left with the negative 2 in front of the exponential function. And then when I plug in 2 for x here, 2 for x here, and 0 for y here, I'll get 8 minus 4, or just 4. So 2e to the 4, negative 2e to the 4. And then f sub yy at 2, 0. Okay. If I plug in 0 for y here, I get a negative 2 in front of the exponential function again, and it'll be the same values of x and y that I'm plugging into the exponential function, so I'll get e times e to the 4th here as well. And then when you evaluate the mixed partial, the mixed second partial, at 2, x equals 2, y equals 0, this whole thing just zeroes out because y is 0. So you get f sub xy of 2, 0 equals just 0. So now when we find that quantity d, remember what d is. D is f sub xx times f sub yy minus the mixed partial squared. So that gives me, well, f sub xx times f sub yy would be what? 4e to the 8 minus 0. 0 squared is 0. So I just get 4e to the 8th, which is greater than 0. So we're in business. And what I'm going to do next is I'm going to evaluate the critical point at f sub xx. I'm sorry, excuse me. I'm going to evaluate the critical point in the second partial. I've already done it actually. And if you look right up here, I have that f sub xx evaluated at 2, 0 is less than 0. So that by the second derivative test, because d is greater than 0, and f sub xx evaluated at the critical point is less than 0, f of 2, 0 is a local max. And that equals e to the fourth.